everybody. So I first kind of want to start out this presentation with a little game. I have to call it to be or not to be. So your goal is to guess whether or not the insect is a bee or not a bee. Bee or not a bee?
Not a bee.
This is a bee. Bee or not a bee? Bee. Okay, bee or not a bee? Not a bee. All right, guys, here's the twist. Bee or not a bee?
Yeah, looks like a bee.
This is a bee. Yeah, y'all did great. So my point with this is that bees are extremely diverse, and I think all of us have this concept of what a bee should be. But there are multiple levels of this diversity, behaviorally, feeding-wise, nesting behaviors, and just other components of their biology. So we're going to start off with bee diversity, and we're going to break it off into a few main components, starting with the taxonomy, which is how scientists like to break apart and categorize different organisms based off things like their genetics, their traits. And then we're going to talk about sociality, feeding behaviors, nesting, and then phenology, which we'll talk about what phenology is in a bit. So first we're going to talk about the taxonomy. There are 7 families of bees, not all of which can be found in the US, but globally there are about 20,000 bee species, 4,000 of which reside in North America. And you can kind of see by this graph, like the very large amount of diversity just within the body plans of each different family of bees. And even within each family, you have a ton of different diversity. Probably a couple of my favorites are Apidae, which have longhorn bees, and bumblebees all in the same family, which can look vastly different.
What are the parts of the bee that make it a bee versus some of the other pictures that you showed us?
Absolutely. There is a portion of that, and you're going to get retested once I tell you guys about that portion of the thing. So pay attention. Go in the grade book, guys.
Jumping ahead.
So more than 77% of bees are actually solitary. However, it's important to note that bee sociality exists on a spectrum. On the extreme end of the spectrum, you have bees like honeybees, that are eusocial, at the fullest. They are the spitting image and poster child of eusociality. And you guys may have learned about that in beginner bee school. There are several different things that categorize an insect as eusocial. A few of them are a primary reproductive, division of labor, overlapping generations. And being, part of that overlapping generation part is the colonies. These insects are typically perennial, meaning they last year after year after year. Bumblebees, things like bumblebees don't quite meet the cut, and we call them primitively eusocial, because at the end of the foraging season, what you have is some young queens that go off and hibernate on their own and start a new colony from scratch. So you don't exactly have that overlap of generations. There's also other bees, particularly in the sweat bee family, which exhibit some division of labor, as well as have a primary reproductive. Carpenter bees can exhibit some social behavior. That was something that I recently learned, where they have different levels of females living in the same colony, and you'll have a primary reproductive, and if something happens to her, a secondary reproductive will replace her. And then you have a tertiary reproductive, which will typically just be fed throughout that year by her, her neighbors, her co-inhabitants of the nest that they're dwelling in. And she will live to see the second year, which she will oftentimes become a primary reproductive in. So that's just to kind of point out, there are so many different social behaviors that we observe in bees. There's also a lot of diversity in their feeding behaviors. Does anybody know what kind of bee that is?
Black and tan.
That's right. So at first glance, this looks exactly like a bumblebee, right? And I'm sure a lot of you guys have gone into your blueberries and seen tons of bumblebees out there. Well, this is actually a specialist bee called Habropoda, which is colloquially called the blueberry bee because it is a blueberry specialist. And they are responsible for giving us significant yields of blueberries. And with without them, we'd be down some fruits. And oftentimes people think, oh, well, I need to put honeybees on my blueberries, or I need to let them do the work. Well, there are tons of native bees that will oftentimes come in and do the same work, oftentimes even better work, because they evolved alongside these plants. Blueberries are native to North America, as are these bees here. And then you have other bee species that are generalists, like this Lacioglossom here, really, really tiny, kind of shiny bee. I'm sure some of you have kind of seen them. They're called sweat bees sometimes because they have a habit of landing on you and drinking your sweat. But yeah, they are generalists, and they don't really have any floral preferences. So more on this feeding behavior. This is a image of a honeybee performing something called nectar robbing, which is where the bee kind of cheats the system and bypasses the main opening of the flower, and therefore doesn't provide any kind of pollinator services, but it does get access to the nectar. However, the Habropoda that we talked about, they don't do this. So they're going to be reliably pollinating your flowers. Other things that will determine a bee's feeding behavior are things like their size, the length of their tongue. I'm sure you guys have seen a lot of carpenter bees. They tend to land on more open-faced flowers like daisies, passion flower, things like that. Any questions so far? I think we're doing good, hopefully. And as we'll talk about the life cycle. So this isn't too different from the honeybee, generally speaking. You have an adult which will pollinate and forage for some resources, which she will store in a nest for her young to feed on and develop into pupa. I will say, the pupal stage, different species of bees will spin this pupal stage a little differently. Some will go dormant in this pupal stage, or they'll hatch as adults, and they'll be dormant as adults, still in their cocoon, and they might come out the following spring. But this really differs on the bee we're talking about. We also have different nesting behaviors. So we talked about them, collecting forage and bringing it back to these nests. But what exactly do these nests look like? Well, there are 5 main categories, really 4. Parasitic is kind of a special case we'll talk about. You have stem nesters, which occupy hollow stems of, I'm sure many of you have probably seen, hydrangea bushes or blueberry canes. They'll hollow out after a little bit, so bees can kind of come inside of those hollows and occupy those. You have ground nesters. I'm sure some of y'all grew up hearing people talk about ground bees. Cavity nesters, which is what honeybees and bumblebees are considered. They'll occupy, hollow trees and things like that. And then wood nesters, like our carpenter bees and other bees. And like I said, we're going to come back to parasitic because they're kind of weird. Oh, and this resource right here, this picture was taken from the Bees of North Carolina, an identification guide, which is a super duper useful resource for identifying bees, especially for like beginners or intermediates, and it can be a great start. And this QR code right here will take you to a free PDF of the book. And I can come back to that later so you guys can see it. So this is kind of a closer look at what a stem nesting bee is going to look like. So this, I think, is actually I want to say a serotype. And they're going to hollow out this stem, and what they're going to do is they're going to lay an egg, give it some provisions, wall it off, lay another egg, give it some provisions, wall it off, and they'll do this a few times until they've filled up the entire stem. And if she is lucky, she can move on to another stem and do the same thing until, the end of her life. Next, you have ground nesters. Ground nesters do something very similar, except they do this in ground tunnels, obviously. I will say ground nesting bees can be kind of interesting. Sometimes you will have multiple bees that will occupy the same nesting tunnel, but they will only take care of their own offspring. So this is part of that, social spectrum where you have bees that are kind of in the middle. And then you have cavity nesters. So bumblebees are kind of oddballs in the cavity nesting spectrum because oftentimes they will form little alcoves in leaf litter. We don't really think of that as a cavity, but it is, and they will build their nests in there. as well as old birdhouses inside of walls and things like that. And then wood nesters, which will, many will bore their own holes or occupy already hollowed out holes from other insects. So we have wood nesters, and then we have kleptoparasites. So this is that weird case that I told you guys I would come back to. So here we have this normal bee life cycle that we talked about. The adult who gathers food, gives it to her offspring, who are going to be in her nest. But then you have the nefarious kleptoparasitic bee, who will come along, lay her egg on the egg of the bee that, established the nest. Whoever. You have to be in the spotlight, I guess. And her egg will hatch out first, and eat the provisions that this bee worked really, really hard for, and sometimes even eat the egg of this bee. I find kleptoparasitic bees to be really, really difficult for most people to ID. So those first two bees in the to be or not to be were kleptoparasitic bees, and you notice they looked a lot like wasps. Not sure the exacts on that, but I find them to be really, really challenging sometimes. This is a great example. So this looks exactly like a wasp, but this is belonging to a species of parasitic bee that specializes in parasitizing Andrina. That's another thing. Parasitic bee genuses have bees that they specialize in. And oftentimes, those bees are in the same family. Nomada is a bit of an exception, but they specialize in Andrina. This is a picture of a Coleopsis, and they specialize in leafcutter bees. So just like those bees that specialize in foraging on flowers, you have bees that specialize on foraging on other bees, kind of. And then we have phenology, which is described by the U.S. National Phenology Network as the study of the timing and cyclical patterns of events in the natural world, particularly those related to animal life cycles of plants and other living things. So this is kind of a great layout of what phenology means to the bee. So this is a graph of Osmia lignaria, which is an early spring bee, a solitary bee. And this kind of maps out their activity across the year. So you can kind of see this is March, April, May, the peak being in this April to May region, and then they kind of drop off as summer begins. So these are going to be those bees that you see when the red buds start blooming, the forsythia is starting to pop out, things like that. And then on the other end, you have Bombus impatiens, which is probably one of the most common bumblebee species in our region. And you can see, starting from June or July, they have a really, really kind of widespread pattern of what time of years they'll occur. And around here, this is probably when you're going to start to see the queens emerging. You see this big spike in occurrence as they start to produce workers, and they go out to forage. They'll produce new queens that go out and start to forage and find places to hibernate before kind of disappearing for the winter and then coming back next year. So this is another portion of the diversity of bees, is when and where they occur. This is a really great resource as well if you want to learn not only about how to ID bees, but their unique and variable biologies. But this brings us to part 2, which is going to talk about the bees in your own backyard. And the next few slides are just going to be some pictures of bees that you may see, another kind of example of all the different shapes and sizes bees can take. Call this frequent flyers. So we talked about the osmia, which appear at the beginning of the year, as well as things like Calides and Andrina, which you can see are kind of hard to tell apart, and we'll come back to that later. You have Lacioglossus, which are super duper tiny. For reference, this is the petal of a dandelion. So this bee can probably fit inside your pinky nail. And this isn't even the smallest bee that we have in North America. I lumped all these bees together because they're oftentimes really, really hard to ID outside of looking at them under a microscope. but these are what we call the green bees. The Agapostamon, Agochlora, Agochloropsis, and Agochlorella. They all have similar names too, so it can be kind of tricky. Let's see why this bar is under here. I can get rid of that so you guys can see a little better. Oh, okay. All right, next we have the Halictus. There it is. And we have about 5 species of Halictus in North Carolina. There are another species that are really, really hard to ID. 2 in particular are so difficult to ID that the only way we can separate them is by genetics.
Wow.
You have Megachile, and I'm a really, really big fan of Megachile, except for the fact that they sting you a lot when you're working with them in the field. These are the only bees, I've worked with honeybees, bumblebees, all these other bees I've shown you. These are the only ones I've gotten stung by. We have an invasive species called Megachile sculpturalis, which is about yay big. It's about the size of a carpenter bee, and they're actually known to kick carpenter bees out of their nests. They're becoming quite the pest as they compete, not only for foraging resources, but for nesting space with our native bees. But I have gotten stung by one of those, and it is not fun. Then you have Epimelosodes. You may also hear this be referred to as Sebastra, but recently they just changed it over to Epimelosodes. The common name for it is a sunflower bee. And they're really hard to separate sometimes from these bees right here, Melosodes, which are those longhorn bees that I talked about. You can kind of see how they get their name. Sometimes these antennae will reach all the way past their abdomen. Then you have carpenter bees. I'm sure everybody's familiar with these guys. This is our largest bee. And then you have bumblebees. So now we're going to start talking about how you separate and tease apart what's a bee, what's not a bee, and what is it if it's not a bee. So bees typically have 2 pairs of wings. You can see here the forewings and the hind wings. And bees usually, there's always an exception somewhere, have branched pollen collecting hairs called scopa under their abdomens or on their hind legs. That's what these are right here. These hairs right here are called scopa. Where honeybees and bumblebees would normally have a forbicula. On Megachile, these would be underneath the abdomen. So the exceptions are male bees. So since male bees aren't collecting for any young, they aren't going to have any scopa. They oftentimes will have some kind of plumage here, though, that kind of lets you know that this is probably a bee. And parasitic bees are also an exception because they can be really hard to distinguish from wasps. As you can see, this guy's pretty bald. Matter of fact, all of this yellow are really, really tiny microscopic hairs that you can really only see under a dissecting scope. But this is one of those things, some people ask me, how do you know it's a bee? And I know it's a bee because I do. Just do. It's one of those gut feelings that you kind of develop as you get to know these animals a little more.
Do the wasps have the ocelli also?
Yeah, so ocelli is a trait that you see across the insect order. Many different insects will have ocelli. Ants will have ocelli. And then you have wasps. So wasps also have 2 pairs of wings, but they usually have a skinnier and longer overall body shape. I'm sure some of you have probably heard the term wasp waist. But bees can sometimes demonstrate somewhat of a wasp waist. So this can be kind of a tricky trait to use. And sometimes wasps don't exhibit a wasp waist. So you saw this picture earlier. This is a cuckoo wasp, which is a parasitic variety of wasp, and it almost looks like those green sweat bees we were talking about. I like to distinguish them from sweat bees from this really compact barrel shape. They look really, really squat. And then you have flies. This is probably the easiest to tell apart. You have all these mimics that these bee wannabes, but they only have 2 pairs of wings, or 1 pair of wing rather, and they have these really, really small thread-like antennae, and these massive, massive eyes. However, BID can be extremely difficult and oftentimes requires the use of a microscope and other tools. Sometimes even the experts get it wrong. I'm working on a project right now where I'm having to go through over 1,500 bee specimens. And I'm pulling my hair out a little bit on some of them because they have given me so much trouble. And oftentimes we're using identification data that hasn't been updated since the 60s. Yep. And bees can, I'm of the suspicion that bees have a more variable morphology than we give them the credit for. And that sometimes these traits that we say only belong to this bee aren't so concrete. A great example of the difficulty of IDing bees I talked about was these Halictus ligatus and Poii. These two bees are genetically distinct, yet morphologically indistinguishable. You know, you can look at these bees under the microscope all you want, and you cannot tell them apart. One of the ways that you can kind of tell them apart, if you're within the proper region, is where they've been, caught. So ligatus typically will occupy higher altitudes. It prefers things above Virginia. Poii is kind of south of Virginia. However, there is a overlap of the range, and we just happen to fall right in the middle of that overlap. So every time I get one of these bees, it's a bit of a nightmare.
Was that the study that was just published last year?
It was by Dr. Hannah Levinson. She just published it discussing how these bees are distinct species. You can see it geographically, however, morphologically they are twins. So some really great BID resources if you wanted to get started in BID is that book I was telling you about. It's a great beginner resource if you're looking to be able to identify the different families of bees and sometimes the genuses. Oftentimes the details that this book provides are things you might be able to see under a magnifying glass. Maybe you don't need a really, really expensive dissecting scope. And if you're really trying to get into it and you want to be an expert, get you some pinning supplies, some nets, and a dissecting scope. You can use Discover Life. This is what my team uses. I find it a pain in the behind a lot of times. It uses really, really hard to understand language, sometimes conflicting language. It's, once again, drawing on those 70-year-old resources that haven't been updated, but it's kind of the best we've got. So this is our game again, to be or not to be. Does anybody need a refresher? Have any questions about what's a bee, what's not a bee, and why? All right. So is this a bee or not a bee?
Not a bee.
It's a bee. I kind of threw you off for a loop on this one.
Kind of got a wasp waist.
It does have a little bit of a wasp leg. It does.
It's got 2 sets of wings.
So this is a male Agapostamon. So we talked about males not really having a whole lot of collecting hairs. And you can kind of see that here. Compared to that one bee I showed y'all, this is kind of got naked legs. But it is still pretty hairy. And it's a little compact. It doesn't have that really, really pointed abdomen like a lot of wasps do. And the females of this species either have an all black abdomen or will be all green. What's this guy?
Not me.
Exactly. So this is a fly, and we can see that it has how many?
Big eyes.
Big eyes, no antenna.
Yep, and we have these little bitty tiny guys right there. No antenna. As a matter of fact, I don't know if you can see this picture. Instead of the second set of wings, they have these little things called hamuli, which is where they used to have a second pair of wings. And they're these little tiny balancing weights. Have you guys ever wondered how flies are able to change their flight path so quickly? It's because they have these little things called hamuli which act as counterbalances. And they have a gear and shifting system, much like a car does, that allows them to move and lock these hamuli in place to counterbalance in a specific direction. They can move them independently of each other, but those hamuli are also connected to the wings. So it's this really complex system of coordinating muscles and counterweights. Just a little side fun fact.
No, those are the same hamuli that in the honeybee.
Oh, I'm sorry, not hamuli. It skips me now, but they have these little counterweights right here. I'll look it up at the end of this if y'all are interested.
Well, then you need to tell them what hamuli is.
So a hamuli are these little Velcro attachments that things like bees and sometimes wasps will have on their forewing and hind wing that when they're not folded behind their back, allow them to clip them together so they get larger surface area. So what is this guy? This is not a bee. So this is another tricky case. He's really, really hairy, but he's got a really long body plan, and it's super pointed at the end. And he's got a little bit of a wasp waist here. So that's a scoliated wasp, which is actually a type of, I believe, parasitic wasp.
That's a bee.
Excellent. I believe this is an andrina. And this is a great example of the scopa at work.
It's a bee.
So what do we see right here?
Squat, not pointed.
These are those scopa that we were talking about. This is a whole bunch of pollen. So this is what leafcutter bee. Remember we talked about them having scopa on the underside of their body. So what's happening to these bees? Why are you worried about them? What's going on? So one of the biggest threats to these bees is habitat loss, which takes place in many different ways. The big way right now is climate change. So as bees are facing a rise in temperature, changing weather patterns, we just have this massive storm in Helene where we saw a huge 100-year or 1,000-year flood event, I think it was. And we don't exactly know how these flooding events may affect ground nesting bees. How do temperature fluctuations affect when, early spring or late summer bees emerge? Are they going to emerge too late and their flower resources are going to be gone? Things like that. We also have urbanization. So I'm sure many people probably have a beautifully mowed lawn or have, driven by so many beautifully cut grasses, but in reality this is an ecological wasteland. Not just to bees, but to any animal. Grasses offer very minimal, lawn grasses offer minimal ecological services. And agricultural practices. So current agricultural practices, the way we have massive monoculture crops, they don't offer bees the kind of dietary diversity they need. How would y'all feel if y'all only ate, pizza your entire life? Not great, I imagine. And neither do these bees. Oftentimes on the borders of these fields, you'll see like goldenrods and asters and these like little scarce small habitats. These are really important for bees. They can oftentimes be pathways to, more advantageous foraging environments, nesting environments, but they're these little patches, these little safe havens for these bees to forage on. And these kind of meadow borders are being pushed back and eradicated. Emerging pests and pathogens are another threat. So this picture is a picture of a parasite called Cryptidia bombi, which is what I studied in my last research position. This is a parasite, a gut parasite, kind of like roundworms or something like that for us in bumblebees. And recently it was discovered to be able to jump hosts. So not only can it go into bumblebees, but now other native bees can capture it. And we aren't quite sure what that means for these other bees, but we know that for bumblebees, it leads to lower survivorship of queens and lower productivity. And we are also facing a growing threat from pesticides. So pesticide misuse, pesticide overuse. I think we have a lot of agricultural intensity that may not need to happen. I think oftentimes we overproduce and overinvest in certain crops rather than a diversity of crops, which means that we're also overinvesting in an abundance of pesticides to manage these crops. How can you help? So there are a few different ways to help, kind of ranking in involvedness and intention. So kind of on the lowest level is leave a patch of yard for the bees. Maybe that edge of the yard right by the woods or by the field, you can leave that for the bees. I mean, if you leave a patch by the field unmowed, you can sometimes create a buffer that can help kind of dampen any kind of pesticide blowover and things like that. Use pesticides responsibly. Read the label. Make maybe try an alternative to pesticides. There are some great alternatives, whether they be mechanical or, alternative natural remedies. And then you have, the more kind of intense intervention plans. Start a native pollinator garden. I kind of emphasize the need for native plant gardens because you'll oftentimes get all of these resources that tell you, this plant is great for bees, this plant is really amazing, it's fast growing. Okay, but is it from here? Is it going to outcompete other plants that are used by other animals? We talked about the specialist bees. There are other specialist bees out there that rely on plenty of native plants. And if we're planting non-native plants, we're not doing anybody any favors. And oftentimes these native plants are better adapted to our environment. You can also plant gardens that work for you. There are studies that show if you plant pollinator gardens in conjunction with agricultural land, whether you have a small scale farm or just a little home garden, that planting these pollinator plots can lead to a greater level of biodiversity. You can support predator insects that can help lower pest loads on your crop yields. Supporting bees to pollinate your plants can result in greater crop yields. I worked on a project this summer where we planted pollinator gardens and we studied what bees were visiting them. And several of the plants we planted were herbs, native herbs, things like bee balms, which I, with the permission of the farmers, was able to harvest, and I made teas out of it this year. And when thinking about habitat restoration and planting these gardens, think about bees throughout the year. So we put out flowers, great, we help them survive. But if we're not doing any long-term intervention or management after that, these bees still might not be doing great. Maybe consider leaving some of the dead stems on your plants for those stem nesting bees we talked about. Maybe you leave a patch of your lawn kind of bare for those ground nesting bees. Here's some really, really great research and resources that continue to talk about that. So this is a resource from the Xerces Society that talks about, starting pollinator gardens and the different threats that pollinators face. And this is a extension document that was actually published in part by my current employer about when do you cut back plant stems to prevent, destroying any stem nesting insects. And then lastly, we have this really great resource that kind of just summarizes in greater detail all the different threats that I just mentioned here today. And if you guys need to scan any of those, just let me know and I'll go back. Any questions?
What type of bees are found all around us?
All around us. So some of the most common that I see in my field work are, we're going to kind of these bees right here. I catch a lot of bumblebees and carpenter bees, melisodes, sunflower bees, things like that, leaf bees. But I will say, it can be extremely regionally dependent. Your neighbor a mile down the road might have different bees than you do. Many bees practice something called nest site fidelity, meaning that these bees have found a really favorable patch of nesting area. Like brown bees, for example, are a great example. They found a really great patch of dirt that has the right consistency, it's bare, and they will continue to come back to this site year after year. And your neighbor down the road might not have that, but he might have a great collection of plants that offer really nice stems for stem nesting bees. So he might have things like osmia and serotina. So it can be really regionally dependent.
So when you say regionally dependent, does that mean like if you have in your yard and you do more of these things like leaving stems and having bare patches and letting things go, that you'll get more variety?
That's very possible. So one of the things that is currently under research is how well bees can migrate across different habitat. And that's becoming increasingly difficult when you do have things like, a really pretty, pristine piece of woods, a mow lawn, and then a really another, pristine meadow. These bees oftentimes have a really difficult time jumping over these wastelands of no habitat. So it's kind of a joint effort, the more people get involved, the better these bees can diversify and spread out. But absolutely, if you do some remediation efforts in your own backyard, you may see a greater diversity of bees. For example, in our own backyard, we stopped mowing certain patches. I've found species of bees that I, don't observe all the time. Longhorn bees have returned. Obviously the parasitic bees that, parasitize off of them have shown up too. Leaf cutter bees, ground nesting bees, all sorts of things.
So the carpenter bees really love my house, and I would like for them to relocate. How can we do that?
I have actually had some success with putting out kind of decoy logs for them. I have observed that they have a preference for softwoods, so things like pines, some cedars. They're kind of okay with some cedars, but if you have like an old pine tree that got cut down, maybe leave a few stumps out for them. They will occupy those nests, and oftentimes they will reuse old nests. So if you leave that there for a while and they get a bunch of holes, don't throw it away. Don't think it's all used up. They'll come back to those holes. And just continue to fill up the ones around your house, and they may find that it's too much trouble to keep coming back to your house and find this log that is perfectly usable.
These like my front porch.
Your front porch, I imagine, is some pretty pine, isn't it?
I don't know. Like, the wood.
Yeah. They'll be in there.
Porch.
I would recommend the following year, in early spring, coming back and during the day when they're going to be out and about, filling those holes, and perhaps leaving a log outside.
What do you fill them with?
They have expanding foam that works. Obviously, you probably don't want to use the insulating foam that expands like 5 times the size, so you'll split your timbers. But maybe use something like a lower grade sealant, maybe some caulking, something like that.
I think that's a hornet's
Yes.
Do ground bees sting?
Do ground bees sting? All bees will sting, except stingless bees, which do exist. But I find that it's really hard to make those bees mad.
I went to look at some of the Rocky Mountain ones that they were all ground bees, but they were just flying around.
Absolutely, they are super busy.
They were so busy that they didn't even pay any mind, they just hanging the pucks around all their holes.
Yep. Oftentimes, if you observe like a swarm of ground bees like that, what you're seeing is males knocking on all the ladies' doors. And they will do it in the hundreds. I've gone out to sites where you'll have thousands of ground bees crawling with male bees going around searching. Hey, are you home? Are you home? But yeah, they typically won't bother you. And the only times I've gotten stung is when I'm doing things I ain't supposed to be doing. It's when I put them in test tubes.
Now we see commercial products advertising like homes for mason bees.
Yes.
Are mason bees an actual real thing, or is
Yes.
that, is that a class of these types of bees?
That is the common bee, common name of this bee right here, osmia. You'll also see these guys will occupy these bee hotels. These are more of those stem nesting bees, so in the wild they do go into stems and things, and we're just creating a really compact artificial area that has all these stems. There is some research that shows that you have all of these bees, living in close quarters with each other, which they might not normally do. On a plant, you're going to have a bee over here and one over here. What happens when we get together in really tight spaces sometimes? Well, we get sick. We spread disease. And there is some, there is an argument to make, and there are some research papers that are kind of, talking about how bee hotels might be a place for pathogen spread, especially when we see things like chlamydia emerging and other diseases. Also, Nosema is capable of jumping bees. There are several different strains of Nosema, some of which can be found in your smaller pollinators, like bumblebees and osmia and things like that. When I was researching Perfidia, it wouldn't be uncommon to sometimes find them in our research colonies. Anybody else?
Thank you so much.